also, like I say, okay, I need to let you all know where is the lab, because your class start at 8. So I don't want you all to come to UC that time, okay, searching high and low, okay, for the lab. So just now, okay, now how am I going to get my hand? The other day I can show you, okay, to another group of students, but come to you all, okay, I couldn't find my hand already. I need to enlarge and show you all this location. This is the one. Okay. Okay, now not sure whether you are coming in, okay, by driving on your own or sort of, okay, take the UC bus provided, okay. Now, this is the Thai UC main gate. So if you are coming, okay, by bus, okay, sometimes they will drop you at the main gate here. So you have to walk in, okay. So so we talk about, okay, those drop, maybe parents also drop you here, then you walk in, okay. So Thai UC main gate, guard will, last time they will check the student's ID lah. Now I'm not sure. Now they maybe check whether you already taken your vaccine or not. Okay. So anyway, be prepared. All right. So at this main entrance here, okay, there's a guard house. So you walk terus jalan, jalan until now you jalan further in here. So you are going to see walk straight, okay? There's a junction, cross it, you just cross it. Then you are going to see your this canteen, a canteen. Okay, if you come early, I suppose, okay, canteen start operations already. You can take your breakfast here. Okay, then after taking your breakfast, there are many ways. Take the easiest one. So go further up. Okay, go further up. Go further up until you see a block M, and this is where the bangunan, our 4A office, Faculty of Engineering and Technology. You will see at the side here. Okay, you will see at the side here. Then there is a few steps of staircase. You go up. Follow this M block, jalan until the other end. Then you also see another staircase. Go up. Okay, go up. Then you see the road, jalan. You follow the road, you jalan. Then you will find that, okay, your block. Okay, block, don't know label. Okay, block Q is over here. Your lab is in the block Q. Okay, block Q is over here. Now, when you terus jalan, you are going to see that here on your left-hand side, okay? Oh, quite far away. Yeah. Okay, quite far away. After the library, go further. Okay, go further after the library. You will see two big buildings. One is called R, the other one is Q. So you look for Q. You are going to find that the building is a bit funny. You have to go down, then go up. Okay, Q200 means that it's a second floor. 202, second floor. 100 is the door number, start from 00. So you go down, you go up further. All right, look for a door label with Q200. It's actually the highest level of this building here. All right, I will be that day. I hope, okay, traffic is okay, so I will be there early. Maybe I will stand at the side there whereby I can see from outside lah. Well, I'm not sure whether you all can recognize me or not. Okay, so I will wait for you at this Q200 here. Okay, so this is the way of you walk. All right, you go through your M block, go straight away, come to here, pass by your library. Library, the main entrance is here. This is the belakang, then you go further up. Okay, until actually no road already lah. Then you will see two big buildings. go to the left-hand side. That is your queue here. Okay, by walking. Okay, if you are coming, okay, driving with your own car, of course, you start from the main entrance also. Okay, main entrance. Well, I am not sure whether they will allow you to enter or not because you got no car sticker. All right. So anyway, ask and see. If not, then very susah for you to find a parking. But because your class is at 8, outside, okay, on the roadside, there are these parking one, legal parking. So, okay, so you can park outside the legal parking here. Then you walk. If not, okay, if they allow you to enter, then you enter. Okay, drive through here. Follow this one, don't turn. Then go up. Go up here. So you find here, now big car park here. Okay, you park somewhere here or here. Okay, so if you are parking here, you find that, okay, you actually can cross it from here. Okay, or go through your library. Okay, from the library, there are jalan here and come to this side. All link one, okay? So you can just cross it, come to this side, and same thing, you look for your Q block. Okay, don't be late. Okay, the 2 hours, okay, we will do the D2 board. I already upload, okay, how to do it. Okay, already on the recording link there. So if, okay, we cannot do it fast, okay, then you have some time to discuss about your assignment, form your own group. Okay, do your assignment. Or if you all want, okay, there are these scope function generator there. You all want to sort of test out that one, no problems. All right, remember the last semester, we don't have a chance to touch all these equipments. So inside these labs here, they have also equipment. In fact, okay, the analog lab is also inside here. So Thursday come already, Friday, I still have to come here, okay, for the analog lab for my SEM 1, RE2 SEM 1 students, hands-on. Okay, any questions? Yeah, I will upload the D video. Songjian will fetch you okay, from LRT station to Thai UC. Yes, there are UC bus. Okay, got UC bus. You can just get up the bus. Then they will drop you at the main entrance there. No booster jet. Yes, I think two after the second jab you can enter lah. The guard may sort of check you on this. So if you are taking the Rapid KL, you have to pay for it. If you take the UC bus, okay, free. Last time they only see your student card lah, but now do you all have a student card lah? Tak ada ya lor. Some got lah. Brian offer anyone stay in Sungai Buloh Brian okay wanted to carpool you, send you there, or maybe in the Kepong. I'm not sure. Okay, I'm not familiar. Okay, so Brian are going to drive there. No need fetch. Minh Hang and Zhen Wei, Kok Wing. Sungai Buloh very far away from Kuala Selangor. This one you all discuss, okay, on your own. So I hope all can come, okay, for this time. So you all think about, okay, how to carpool it. So now after my class for 3 hours, okay, what else? Do you all still have classes, okay, in the afternoon? So you all ask the lecturer whether you all want to do online or face-to-face. So since you are in the UC already, you all discuss with the lecturer. So you can take your food at the canteen there. All right, canteen food is quite reasonable. Okay, you can take the food at the canteen here. There are mama stall. Okay, last time lah. For long time I never enter already. Last time got this mama store, got this Malay food, got Chinese food, okay? So over here. Now, my office is here, okay? If this is the canteen, you cross the canteen, come to C block. My office is here. C block, the top floor, C300. See enter the door outside label as C300. Go in, then you find small rooms, okay? So my office is here, the year 1 lab by right. Okay, your this digital logic design lab, your basic electronic lab will be somewhere here opposite, same floor, can jalan through one. Okay, so it's here. So next time can enter already. Okay, you want to find me physically, I will be here. Okay, in the C block, cross to the canteen. Actually, okay, anywhere you jalan, okay, if you miss out, right, actually you can just go through one further up, ask people where is the Q block. Okay, first you find the block first, so you jalan very far away. Okay, this is the one. Now here can see very far away one. Okay, you just walk up, then you can find your Q block. Okay, where do I get this map here? I got it from this. I go to the faculty. This faculty. All right, I click on. Sorry. I go to the faculty. Okay, this part here, I go to the faculty and center. You may need this one, okay, when you come in that time. Okay, faculty here. They're at the bottom. Mana dia? Oh, because I didn't pick. Okay, so I pick, let's say, faculty. Our faculty is engineering and technology. So towards end at the bottom here, now you got the college map. Then let's say, okay, in the morning you really lost your way. All right, I go in already. Okay, I will check my this. I will turn on my this. Set up my PC lah. Okay, then you all can Google check me. Okay. Or you find any people who are elderly, more elderly one, ask young one like you all, maybe also blur like that. After 1-2 years, or even sometimes maybe never enter UC before. Okay, just find out, ask for Q block, Q. Okay, so you can get the map from here. Oh, there's a map on intranet. So not sure. Okay, I was trying to find, but I couldn't find. Okay, I'm not sure whether is it better than what I show you. Okay, where is it, Kok Wing?
Somewhere at the announcement.
Is it better than the one that I show you? Control F, find map. Other. Maybe you can share out, okay, the location clearer one. Okay, so any questions? So I will see you all, okay, 8 o'clock in the morning in Q. Or do you all want it to start at 9? Because I am free after your class. So I'm afraid that, okay, you all lost the way, things like that. You all want to start at 9 until 12? Then I tell the lab assistants we will come at 9. But I will be there slightly early lah. Class? So do you all want to have all 9 to 12? Must all agree, Anybody disagree? So I will later on send a reminder in the classroom, okay? So our lab start from 9 to 11. Then the 11 to 12 we do lecture, and we stop at 12. Okay to all, I will send a reminder. So okay, otherwise, okay, you lost your way, then very susah. Okay, if no question, I think this part here is clear now. And next now we back to our class. So Thursday, later on I send in the classroom there. Okay, so now, like I say, okay, this hour here, I will do a little bit something like your revision. All right, revisions on these NAND gate, NOR gates, and so on. So now you are going to find that, okay, for our this syllabus here, I need to cover the circuit, okay, or the kernel maps here based on 5 input variables. But 5 input variables here actually also, okay, related to your 4 input variables. All right. So this part here, maybe I record lah, Take it as something like a revision, Okay, enter. Okay, blank two table. Now you are going to find that, okay, if we are talking about kernel map, 4 input variables, try to recall. We will start off with, okay, preparing a kernel map, okay, because of 4 input variable is 2 to the power of 4, then I should have 16 different combinations, okay, different 16 combinations. Then these 16 different combinations here will have 16 different output. So I prepare a kernel map 4 by 4. When you prepare kernel map that time, be very careful of finding writing this part here. You have a 0, 0, here 0, 1. Here, not 1, 0, but 1, 1. 1, 1 followed by 1, 0. Same thing, go this way. Now, in kernel maps here, I can only accept, or we are supposed to generate, okay, change of location from here to 1, only 1 bit changing. In this case here, the second bit. This one here, first bit. This one here, second bit. And lastly, okay, this one back to here, okay, you find that first bit is changing. Okay, so you can imagine that this kernel map here, you can actually flow it vertically, even, okay, fold it horizontally, because here to here, 1 bit changing, 1 bit changing, change means from 0 to 1, or from here to here. Go up also same thing. Here from 0 to 1. Here go up 1 to 0. This one never change. So whether you are moving up, moving horizontally, backward, moving down, or, okay, is a 1 bit change at any one time. Now, if you have 4 bit of input here, then you are going to find that, okay, you need to label your input variables at the side here. Let's say I tell you I write it this way, A, B, C, D. That indicate to me this one represents C, this one represents D condition. This is the A condition, B condition. All right, can do it this way. You can have your AB written as in this case also. If you do it correctly, answer finally should be the same. Okay, so there's no rules, okay, restrict you, must do this way or this way. Suka hati, which one you are familiar with. Okay, that is how we do our kernel map. So this is for input of 4. So just a little bit of looping, okay, revision. Let's say, okay, in this kernel map here, I have 1, 1, 1, 1, then another 1 here, another 1 here, 1 here, 1 here, 1 here. Okay, these are the one that I have in my kernel map. Then you are going to find that, okay, I need to do looping. So my looping here is, okay, always set the criteria is loop as large as possible. Okay, bigger loop, okay, you are going to find that the expression is more simple. All right, so like in this example here, I want to do looping, but looping is something like that. You can only loop one. Of course, no, very lonely lah. You just loop one only. Or you loop 2, 1 together. You loop 4, 1 together. You loop 8, 1 together. If all are 1, then I loop 16, 1 together. All right. And looping can only be horizontal you get a horizontal rectangle or vertical rectangle or square. You cannot do a looping like this. Okay, here got a 1, here got a 1, then you loop like that. No, this is not allowed. This is diagonal. And you'll find that, okay, I cannot actually simplify this. Looping is meant for simplification. This one cannot be simplified. So this loop is invalid. For us to do looping in this case here, first I try to loop these 4 together. So when I'm looping this one here, this loop, I check, let's say, start from here first. I find that, okay, my A is keep on changing from A, from 0 change to 1. B is not changing. So this part here, I got a B, which is a 1. Okay, B, which is a 1. So for this loop, I got a B first, horizontally. Then vertically, you find that, okay, my D is no change, but C keep on changing. You eliminate the one that is keep on changing. Okay, you got your D. Okay, this loop will produce BD. BD. Okay, BD. So, all right, done for these loops here. Then next, 1, 2, 3, 4. Remember just now I said you can fold them. When I'm moving horizontal, vertical, up or down, you find that, okay, only one bit is changing. So for these loops here, I can loop these 4 together. Okay, so looping these 4 together, I first, okay, check which one is keep on changing. I'm going to eliminate you. Keep the one that is not changing, but B in this case here, okay, is a 0. So you put B bar. All right, so I check horizontally already. Next, I check vertically and find that my D is the one unchanged and D is a 0. So this loops here will give you the B bar, T bar. Okay, next. So you have a 1 here. This one here, actually, suka hati, either one is correct. You can loop it this way or this way. Both are correct. So if you look it this way, you are going to get that the expression for this one here, A is not changing, but A is a 0, not changing, 0. B keep on changing, eliminate. So you get your C D bar. Okay, and whereas for this one here, okay, you have is a brown color, which in this case here is A bar B. This one here, C. Okay, so what is the final result for this truth table here after applying the looping techniques? Okay, after simplifying, then you're going to find that, let's say the output I refer it as F. So these two are the mass. Okay, B bar D and BD are the mass. And another one, I'm going to put it this way. Okay, plus with A bar. Okay, this one, or. So that is to say, okay, when you are writing the answer or even you implement the circuit the time, you implement either one of these together with this one. So all these are what we call as prime impedance. Okay, prime impedance. Okay, prime impedance. These two are the essential one. Must. These two, one of them. Okay, you generate your expression for the F. Okay, so a little bit of revisions on these Kano maps here. So of course, okay, our Kano map here can be more simple, like using, okay, only 3 inputs. Then if it's using 3 input, then you find that, okay, I will generate something either horizontally, all right, or vertically. Both can be accepted. Okay, so here you put A, here you put BC. If you don't like it, you put AB here, you put AB here, the bottom you put C. If you do it correctly, final answer is the same. Okay, this is the Canumet. Next, a little bit of revision on truth table. Let's say this is a 4 input. Just now I label A, B, C, D, right, as my input, and F is my output. Then you are going to find that you need to prepare the Canumet, let's say for all. Make sure that keep on changing 0, 1, 0, 1, 0, 1, 0, 1. Okay? Everything 0, 1, 0, 1. Keep on changing. Okay? How frequent do they change? Every one time. Then C, how frequent do they change? Every 2 times. 2, 0, 2, 1, 2, 0, 2, 1. B, in this case here, how frequent it change? 4 times. 4, 0, 4, 1, 4, 0, 4, 1. A, okay? 8, 0, 8, 1. Okay, so prepare all this, okay? You find out, okay, you won't miss out any combinations. Now, you can label it as ABCD, or you can label it as DCBA, things like that, or ABCD. Okay, if you go according to this, method here, you will have all your combinations being generated. Okay, let's say now my F here, okay, got some output of a 0. I simply put one put more 0, then I got less problem. Okay, 1, 1, 1. Okay, so let's say this is my F here. Okay, so I can write my F, okay, in actually a more complex way is, okay, I generate all this. Okay, so this is A0, B0, C0, D is a 1. So you write it as A bar, B bar, C bar, D. 1 expressions, all. Okay, second one, A bar, B bar, C, D bar, all. One more, all, one more. Okay, all the one, you write it. And you find that 1, 2, 3, 4, 5, 6. Okay lah, put 6 enough already. Okay, 6 terms of 1. So you need to write 6 combinations of this. Okay, so this is one way of presenting your information. There's also another way, okay, which is easier. We use min term. Remember the min term? So we label this one here as min term 0, because if I add in all these value in terms of their weightage, you find that everything here add up is a 0. This one keep on changing. So this part here, assume is like your LSB. The one less frequent changing one here, MSB. Okay, representing 8. Okay, higher weightage as compared to all the rest. So therefore, when here is a 1, you take this 1 times 1. So min term 1. Second one, this one, 1 times the 2. Min term 2. This one, 1 times the 2 plus it be 1 times the 1. Total min term 3 and 4, 5, 6, 7. Okay, why this one called 7? This is 4 plus the 2 plus the 1 that give you the 7. Okay, further, this one here, what is the min term for this one here? So this is 1 plus 4 plus 8, so 13. Okay, 8 plus 4, 12 plus 1. So min term 14, min term 15. 0 to 15 total. All in, there are 16, okay, min terms in this table here. So why tell you all this? So my function can also be written as min term 1, min term 2. So instead of writing it this way, I can write it as this form. 1, 2, this is 4, 5, 6. 4, 5, 6. Plus another one, 13. Okay, 13. So this is one way of writing, or I can write in this form. Summation. Why? Because this is plasma. All functions. I write here 1. So 1, 2, 4, 5, my 6, my 13. All right. So, of course, this is the easiest. Okay. So, I can sort of, okay, express my output expressions as in this form. So, of course, okay, if minterm a lot, I expect you to write this, okay, very time consuming. And sometimes we do make errors because after writing, okay, we miss out the bar lah, or we add the bar to the wrong input variable. This way is easier. Okay, why tell you all this? So if you were to look at, like I say, okay, this part here is a continuation of another subject. So I don't think, okay, I'm going to give you, okay, very detailed of like a NAND gate, NOR gate, these are of things anymore. I am going to sort of, okay, this part here is like a lecture for 5 input variable. Okay, let's say now I have 5 input, which is labeled as A, B, C, D, E. These are my input variables. How am I going to do, okay, minimization for this part? And these are all the bin terms in the variables plus some don't care. Okay, plus some don't care. Don't care in this case here can be 0 or 1. Okay, can be 0 or 1. So suka hati, the person or the designer, okay, sort of say that, okay, I want this don't care to be a 1, or I leave the don't care here as a 0. It all depends on the looping that we make. If I loop it, okay, min-term looping, I make it become a 1. If a max term looping, I am going to put it as 0. Okay, so now this part here, let's say here I got these functions containing a lot of this min term plus some don't care terms here, and my aim here is trying to find the minimum sum of product. Minimum sum of product, remember this SOP, minimum sum of product. Okay, so if you have a minimum sum of product, you actually can make use of later on, okay, use NAND gate to implement it easily. Okay, but before this, try to find the minimum expressions of this part. You are going to find that, okay, in these expressions here, because it's 5 input variable, so 2 to power of 5 is going to give you 32 combination. The color map that we have learned so far, okay, are for 4 input only. Total here, 16. Not enough. So I may need another 16. Then I combine these two. So since this is 5 input variables, suka hati, you can arrange it as, okay, I take this color map here. In this color map here, everything is A bar. Prime means is bar. Everything here, A is a 0. This one here, everything here, A is a 1. This one, everything A is a 0. So if this is the case here, you find that, okay, I can make use of 2 4x4 color map, okay, to form a 32 output combinations. And next, let's see, okay, the parts here. So if my A is a 0, then you are going to find that it is exactly to say that, okay, let me just modify this one a bit. If my A is a 0, then you find that these parts here is same as saying that this is a B, C, D, E. Your min-term 0 up to min-term 15 is here. And how do I, okay, put it into the, put it into here. So here, this one here actually representing my min-term 0. So I didn't put the M, I just put it at the side here. This is my min-term 0. All are 0. This one is a min-term 1. Okay. Then this is a min-term 2, min-term 3, followed by this one, C, indicating this is 0, 1, 0, 0, min-term 4, min-term 5, 6 is at the bottom, 7. After 7, not this one, because this is 1, 1, so minterm 8 is here. 9, 10, this is 11, 12, 13, 14, 15. Okay, this is when A is a 0. So this is the minterm location. Next, these two, this is only half, with your A equals to 0. Now, what if, okay, my A is a 1? Then this table we will fill up. So after 15, followed by 16. Okay, because A is a 1. So you see the truth table here. If I now add in one more variable, all will be 0 for the 16 time. How frequent it changes? 16 times. This is 8. So 16 times. Then now you see a 1 followed by 8 and 16 or minterm 16. You are going to see in your this parts here. Okay, 16. And in fact, okay, same location, you find that this one and this one, their difference is 16. 1 plus a 16 give you the 17. So 16, 17, 18 is here, 19, 20, 21, okay, 2, 23, same, shift to here, 24, 25, 6, 7, 8, 9, 10, 31. Okay, so these are the minterm locations. Once I know these minterm locations already, okay, I can actually try to fill up. Okay, try to fill up. In my this case here, F, okay, is under this type of expression. So minterm 0, my output is 1. Minterm 1, minterm 2, 6, 7, 9, 10, 15. Okay, so 16, 18, 20, 21, 27 is here, 30. Okay, these are all the minterm that I filled up, green color. Okay, then we add in the don't care term. This one here, D stand for don't care terms. Okay, you can use X to represent. If you don't want, you can use a dash to represent. So I think I still will want to use X, easy to see, because sometimes a dash students will take it as a dot like that. Okay, very difficult to recognize. So I use the X to represent. So 3, 4, don't care. Okay, don't care. Then this is a don't care. 11, 12, 19. Okay, 3, 4, 11, 12, 19. Okay, so these are the don't care that I filled up. Okay. Now, after filling up all these, okay, maybe this is easier for me to see and clearer for me to see is I erase all this. Otherwise, it's very kacau, And now I want to do looping. How to loop, okay, Kanomat in this case here for the 5 input variables. Okay, how to do looping, okay, for these 5 input variables here. Now, always remember, okay, Kanomat, when you do looping, you are actually talking about iterations. Anything that keep on changing, you are going to say that, oh, eliminate it. Okay, because if you have A and your A bar in Boolean algebra, you know that A means it's a 1, A bar means it's a 0. 1 plus 0 is always 1. So the variable missing already, no need to put. If I have a dot with 1, actually finally it's a A. So therefore I no need to write the 1 here. or B dot 1. Finally, you got a B, so you forget about the A. Okay, so this is a concept behind it. Okay, now in this case here, this is the Kano map that I am having, and I'm supposed to do looping. So come to loop that time, so you have to consider on this both sides here. So of course, okay, it will be maybe easier. I just focus on this part here alone. All right, this part here alone. Then you may find that if that is the case, okay, I will loop this one here first. But maybe this is not a very good idea. So anyway, let's say okay, now I try to loop this part here at the time. So let's see. Now I have this okay. Okay, let's start off with this one and this one. Purposely, okay, pick this one here, start first, okay, because it cover both kind of maps here. I look it this way. Okay, so what is the expressions that I'm going to obtain from here? So you are looping on this map as well as this map. Your A is changing. Okay, your A is changing. Okay, your A is changing. So you are going to eliminate the A expressions. BC for this one, BC for this one, both never change and they are 0. Okay, then now I move, okay, this way here, you find that my E is changing, left with my D is not changed. So these loops here give me these expressions. Okay, next. Try to pick, okay, those, okay, I can look one. Okay, I have a 1 here. Okay, this one. So I change color. So you are going to find that I loop this one with this one. And at the same time, I loop this one with this one. So this same color of loops here, this color, maybe I can write here. We go by color. So this loopings here, you find that A will be eliminated because keep on changing. Anything okay, you look on both sides of the both Kano maps here. These are both Kano maps here. You eliminate the A in this case. Then what is not changing? My DE never change. Okay, but my this in this case here B is changing. So this part here is C bar DE. Okay, and you may ask, okay, is this loop necessary? Answer yes, because in this loops here, this one never been looped before. You got a 1 here. So those don't care that I put in these loops here. Actually, I say that, okay, you now function like a 1. You are a 1. Okay, so I'm going to change you to become a 1. Okay, so this is how we plus this one. Okay, then let's see any other loops, okay, that I can do on both sides. Maybe now try to look for this 4. Okay, purple. This 4. Mm-hmm. Okay, so if I have these 4 here, because this 4 can also be something like, okay, I can pick it as a 1, 2, 3, 4. Okay, I cannot remember, okay, my final answer, which one do I pick? Wait, let me just think about it, which is better. Because later on, this one, I will loop it with this. Oh, equally, okay. So I got a final answer here. Okay, never mind. If redundant, okay, later on we reconsider. So this looping here, I loop it this way. So if I loop this way again, okay, my A will be eliminated. What is going to left behind here is a DE never change, but my C is keep on changing. So it's a B bar, D bar, my E bar. Okay, then next. So it seems like, okay, those are, I need to loop, okay, on both sides one, all done. This one here cannot, okay, because this location and this location here, okay, this here, nothing, nothing means it's a 0, okay? So nothing, never filled up one means that it's a 0. So you find that, okay, this one here, I can't loop this way. This one, same thing, I can't because this is a 0 over here. All right, so those that I can loop on both sides one all considered. Okay, so next now we may sort of, okay, focus on this one alone first. Okay, so you find that I got a 2 1s here. Okay, 2 1s here. I may want to loop it this way to cover this 2 1, and this loops here is going to give me, now I loop on this Kanomet alone, so I must include that A bar is in. Okay, the A bar is in with my DE. Okay, A bar with my DE. Okay, next. Okay lah, this color. Then you find out, okay, here these two I try to look this way. Then you find out, okay, I'm going to have this expression here again containing the A bar. Okay, A bar, C is a 0, D is a 0, E is a 1. Okay, next. Okay, now I can put a brown color, okay? Now, I got a 1 here. Of course, you can say that, oh, just loop these two. But in Kanomet concept is that you try to make your loop as big as possible. So if this is the case here, it would be a good idea to loop it this way. Then you may ask, is this loop valid or not? Yes, valid. As long as in any of the loop there is a 1 have not been looped earlier. So this one haven't been looped earlier, then this loop is valid. And this loops here, because it's looping of 4, you are going to have a A bar, okay? A bar with your C bar, then with your D. Looping of 4 give you 3 input variables. Looping of 2 give you 4 variables. That tells me that, okay, bigger loop is better because my expression is more simple. All right. Okay. Then lastly, quite clear that you find that, okay, I am going to loop maybe now black color lah. Okay, these 4 together. Also valid because this one have not been looped before. And when you loop this, don't forget about your A bar. On top, I got my B bar. And this side here, I got my D. It's a 1. Okay, so everything inside here has been looped except this don't care lah. So don't care, not necessarily must do the looping. So if don't care, I never loop. Actually, I want it to be a 0. Or the one that I loop, I want it to be a 1. Okay, so this is considered done. Then these two are 1, so you can't say that, oh, forget about it, don't do the looping. No, must include. So this one must loop. Okay, these loops here will give you, because now I look at the A, so this is the A with never change, B bar, C, this one here, E is keep on changing, D unchanged. Okay. Then lastly, this one here, very pitiful. You cannot do any looping at all. So it is 1 by itself. So if you have 1 by itself, you find that, okay, you need to put in all the input variable, be it a 0 or 1. So in this case here, this is A, B, C, okay, and D, your E bar. Min-term 30. Okay, this is the min-term 30. Okay, so finally, I all this together and I am going to get this answer. So confirm, first one. Okay. Then it's a mask one. So like I say, okay, sometimes, okay, the looping can be this way or that way. So we go for those, it's a mask one. So this four, orange color, C bar, D, E. Let's check the C bar, D, E. Okay, let's check, okay, these are two red color one, which is B bar, D bar, E. B bar, D bar, E. B bar, D bar, B bar, B bar, C bar. Oh, I know why. Okay, like I say, okay, this one, I can have 1, 2, 3, 4 loop together. Okay, so let's modify a little bit. So this one or that one, isn't it? Sometimes we do it as this one or that one. So if I were to sort of, okay, let's say I modify to, I don't want this loop. I take the looping of purple color. I loop it this one, and this one, this one. Okay, then we see the red color one, I can actually also eliminate it. So come to input, 5 input variables, sometimes the looping can be very messy. So the orange color in this case here is going to give me here is B bar, C bar. Okay, on both sides. And then this one here, on this side here is a E bar. Okay, so B bar, C bar, E bar. And you are going to find that if I do this looping here, the red color one is redundant already, because just now I looked the red color one is because this one this one it have not been looped. So now if I do this 4 loops here, you find that the red color one is all the one, okay, inside the red color loops here has been looped earlier. Therefore, okay, you find that it's redundant for the red color one. So I erase the red color. Okay. All right. So all these 4 here has been looped. Then the red color one is redundant. That's why we do finish checking, finish already. Okay, we might do a little bit of checking to make sure that, okay, we have the best loop, minimum loop, largest loop. Okay, that's what we are eyeing for. All right, so now I reconsider the orange color one. So the red color one erase, no more. So this red color one, no more. Just now the purple color one, did I erase? Yes. Okay, then now check, okay. This is looping of 2. You look at 4 input variable, it's a looping of 2, which is actually this one. Okay, A, B bar, C, D bar. Okay, then my A bar, B bar, E bar. A bar, B bar, E bar, where is it? Where is it? A bar, E bar, D bar. Wait, do I miss out anything? Okay, which are the ones that I recheck? Which are the ones that I recheck? So use red color. So I recheck this one. I recheck this one. I recheck the purple color one. Okay, I will check this one. 1, 2, 3, 4. 1, 2, 3, 4. Okay, where is my these are few more terms, okay? A bar, B bar. Okay. So in my these parts here, do I make a mistake here? No. So it's A bar, B bar, black color, A bar, B bar, D. Wow. Okay, let me cut this one and put it on top. Otherwise, okay, very difficult for me to see. Keep on flick here and flick there. Okay, well, let's check, okay, which are the one that I missed out, okay, C bar, D bar, E. So far last time, okay, so never tell me that got error. Now, this one here, okay, A bar, C bar, D, okay, so this one I cannot write, can yeah, okay, A bar, C bar, D, all right, then next is a A bar, B bar, E bar. Oh, this one here, now, this one, this one here, you find that, okay, this loop, black color loop, okay, you can do it this way as well. This is all. All right. You can get your answer either this one or A bar, B bar, D. Both answer are correct. All right. So I've done this. So my A bar, C bar, E, where is it? I see until my eye blur already. Oh. C bar, D bar, E. Okay, so this part of E here, you can do the looping as in this case also. All right, then to form, okay, another expressions here. Okay, double check, okay, all this loop. So here I teach you all the concept. This is the correct answer for some years already, okay, shouldn't be any mistake. So this is taking, okay, my A as the variables for this Kanu map. So you are going to find that, okay, I have, this is one using the Kanu map as provided. And I have another one. Actually, now the column map, I change a little bit to E. I put it down. Okay, E, I put it out. So this is the E bar, this is the E. So, of course, if this is the case here, my midterm location is going to change. All right, so I need to identify the midterm location first, then subsequently fill in the one or the output into this column map. And for both way, okay, for both cases here, if I do it correctly, my answer would be the same. Will be the same. All right, so can try out this and take this one here as a tutorial. This is the answer that you are going to obtain. All right, so today our revision here, Kanu map, and at the same time, okay, we do the 5 input variables for the Kanu map. All right. Okay, any questions before we end for today's class? My eye a bit blur already, okay? Any questions? Now I will see you in the lab this Thursday 9 a.m. So can come early. Okay. I will be there. I think the latest are 8:30. So if everybody come in earlier, okay, all are there already, we can start our class. Okay, any question? If not, we stop here. Okay, no question. Thank you for your attention. See you.